Hey all, and welcome to this video where we're going to look at stationary points. So this is our third lesson on the applications of differentiation, and this is certainly nothing new. We've been smashing this to death in just our basic differentiation stuff in year 11 and year 12. So saying that, I'm going to go through all of this really quickly. All the differentiation, if I'm doing it by hand, is going to be really quickly. I'm not going to explain much. By this stage, it's expected you know how to differentiate these functions. If you need to, though, you can pause and slow down and do checks on your calculator. But yeah, by this stage, it's sort of, you should be working not quite at this speed because you probably haven't been doing it as many years as I have, but you're getting close to it. And if not, hopefully this might be a wake-up call. Right, so let's jump straight back in. So we have a graph of y equals f of x below. We don't know what the equation of it is, but we can see there's a heap of key points. So knowing what we know about coordinates and key points, what can we say about this? So for example, we've got the first intercept over here, which we could write as f of 1 is equal to 0 using function notation. So we can write a key bit of information like that. I can also write another bit of information as the other intercept, which is f of negative 2 is also equal to 0. I can also see this intercept here, which is f of 0 is negative 4. So we're just writing that in function notation. Now the other thing, though, I can tell, both of these 2 points, they are stationary points. The gradient is 0. So I could say that f, the derivative at negative 2 is equal to 0, and the derivative at 0 is also equal to 0. So from this equation, this cubic, clearly it looks like, there's actually 5 bits of information I can write down about it, just by recognizing coordinates and also recognizing any key points or stationary points, which is the gradient is equal to 0. So let's do that again. If you want, you can maybe pause and have a go yourself, and then check your answers. So I'm going to start here. Left intercept, f of negative 7 is equal to 0. Right intercept, f of 5 is equal to 0. Have another intercept, so f of 0 is equal to 350, being my intercept. And then I'm going to look at stationary points, and I'm going to put them in red. So there's my 2 stationary points. Oh, I forgot to label this, though, as a coordinate. F of negative 3 is 512. And now I'm going to do stationary points. So the gradient at f dash of negative 3 is 0, and the gradient at 5 is also equal to 0. So a couple key bits of information. We got 6 bits of information out of that graph. So we can use that, and this will become important, this idea, when we get to the very last slide, which is sort of the only new thing, but we have done it before. A particle is moving in a straight line, so we're just doing an example. Its position x meters relative to the point 0 on the line is given by blah. Find the particle's maximum distance from 0. So its maximum distance is if we graph a distance versus time, the maximum, we do have a domain, so it could happen to be that it could just be like that, 0 to 4, but we also want to check, it might actually be maybe something like that. There might be a turning point in between 0 and 4. So let's find the derivative. So x dash is equal to 4 minus, so we're going to just get t squared. And we're going to let x dash equal to 0. So we get 4 minus t squared is equal to 0. So we get 4 is equal to t squared. So t is equal to the plus or minus square root of 4. So t is equal to plus or minus 2. So we're going to reject t equals negative 2. So we know there's a maximum, we know that there is a turning point at t equals 2. But we don't know yet, does the graph look like that, or does the graph look like that? Could be either one, whether the turning point at t equals 2. But we're going to substitute in a point. Let's find that. So x of 2 can be 4 is equal to 8 minus 2 cubed is 8 on 3. So that's going to be it's the same as 8 minus 2 and 2/3. 6, 5 and 1/3. Okay, and what we're going to do to check if that is the local maximum or local minimum is just substitute in a point just to the left of it or just to the right, and see what that value is. So x of 1, because if it's higher, we clearly got the red situation. If it's lower, we've got the black situation. So x of 1 is equal to 4 minus 1/3, which is 3 and 2/3, which is clearly lower. So therefore x equals 2 is a local maximum. So therefore max distance is at t equals 2. So it follows on that x equals 5 and 1/3 meters. That was the y coordinate or x coordinate at that point, because it's x equals giving a distance. Okay, find the coordinates of the stationary points of each of the following. So this is just following on. What is a stationary point? Stationary point is when the gradient is equal to 0. So f dash of x is equal to negative 6x plus 6. We're going to let f dash of x equal to 0 is equal to negative 6x plus 6. So we get 6 is equal to 6x, so x is equal to 1. And now it asks for the coordinates, so we can't just say what x is equal to. We need to get the y coordinate, so f of 1. And we're finding the y coordinate, not the gradient. So we get negative 3 plus 6 plus 4 is equal to 10 take away 3 is 7. So the coordinate is at 1, 7. Stationary point. Okay, same again. F dash of x is equal to 3x plus 24, 3x squared plus 24x plus 48. We're going to let f dash of x equal to 0. So that's equal to 3x squared plus 24x plus 48. Okay, so straight away now we should be seeing got a quadratic equal to 0, so we should be going through our factorization flowchart. We've got a non-monic quadratic, so we've got this 3 out front of the x squared. So we're either using cross method or quadratic formula, but the very first thing on the flowchart is common factor, which we can take out. We get 0 is equal to 3, take out 3 as a common factor, plus 8x plus 48. Come on, brain work. 16. Is that right? 3 10s are 30 plus 3 6s are 18 gives us 48. Yes, that's correct. So 0 is equal to x squared plus 8x plus 16. 0 is equal to x. Multiply to give me 16, add to give me 8. 4 and 4. Plus 4 plus 4, so it turns out that x is equal to 4. We need to find, again, we're asked for a coordinate, so we need to find the y coordinate. So f of 4 is equal to 4 cubed plus 12 by 4 squared plus 48 by 4, which is equal to whatever it is. I'm not going to waste time finding that out doing the mental arithmetic, but you can. And you would get our coordinate, which is 4, whatever it is. Okay, find the coordinates of stationary points for each of the following. And we're given a condition here that x is greater than 0, so we need to keep that in mind. So y dash, actually I'm going to rewrite it in polynomial form first so I can apply the power rule. So it's going to turn x to the negative 1 plus x. So y dash is equal to multiplied by negative x, take 1 from the power. So negative 1 take 1 is actually negative 2, and plus x is just going to turn into 1, which we could rewrite, depending if it's useful to us or not, as negative 1 on x squared plus 1. We're going to let y dash equal 0, so we get negative 1 on x squared plus 1. So we get negative 1 is equal to negative 1 on x squared. Negative x squared is equal to negative 1. I've just multiplied both sides by x squared. I'm going to multiply both sides by negative 1. So x squared is 1, so that I can then now take the square root. So x is equal to plus or minus the square root of 1. So x is equal to plus or minus 1. We're told x has to be greater than 0, so we're going to reject x is equal to negative 1. So therefore, we're going to now find y of 1. So we get 1 on 1 plus 1 is equal to 2. So the coordinate of the stationary point is 1, 2. And it's good to put SP or stationary point is, or something, just to really indicate to the examiner what the that you have found a stationary point, and that's what that coordinate is that you're referring to. Okay, find the stationary points of each of the following functions. The same thing, find the derivative, let the derivative equal 0. So y dash is equal to derivative of cos. Now cos looks like that, so that is negative 3 sine 3x. Okay, is the derivative. Let y dash equals 0, so we get negative 3 sine 3x. Divide both sides by negative 3 to bring that across, so we get 0 is equal to sine 3x. And we do have a domain, so if we want to be careful, we would need to find a working domain. So our working domain is going to be, substitute that 0 and pi into this 3x, just the composite inside. That gives us a working domain when we're solving this bit. That's going to be 3 times 0 is 0 and 3 pi. That's our working domain. So doing inverse sine of 0 is equal to 3x. Let's write that the other way around. 3x is equal to inverse sine of 0. 3x is equal to, now what angles give me a sine value of 0? That is going to, between 0 and 3 pi, that's going to be 0. It's going to be pi, that's going to be 2 pi, and it's going to be 3 pi. Divide both sides by 3, we get 0, pi on 3, 2 pi on 3, 3 pi on 3, which is just pi. And all of those are inside our domain, so that works. Now it is asking the stationary point, so again it needs to be coordinate. Now you could substitute each of these individually into this function, but we can recognize that the amplitude of this function is 1. There's no dilation from the horizontal axis. So it's regular cos function. We know a cos starts like this diagram up here. So it's going to be 0, 1 for the first stationary point, but the next stationary point is going to be a minimum. So we get pi on 3, negative 1. And then we go back to a maximum. So we're going to get 2 pi on 3, positive 1. And then negative, not negative pi, comma, negative 1 back to a minimum. Rightio, what are we at? 15 minutes already. I'll make this last one, try and make it quick. Y dash is equal to the derivative of e to the 3x is going to be 3e to the 3x minus 3. Let y dash equal to 0 is equal to 3e to the 3x minus 3. We get 3 is equal to 3e to the 3x. Divide both sides by 3. We get 1 is equal to e to the 3x. take the log of both sides, natural log of both sides, so log base e of 1 is equal to, and I'll write it out just as a reminder how this works, e to the 3x, log e to the 1 is equal to, using log laws, technically we can rewrite this as take that power out to the front, 3x log e to the e, and now we're left with log to the base e of e is just 1, so we get log e to the 1 is equal to 3x. Now we need to solve this. Log to the base e, so e to the what power gives me 1? Well, anything to the power of 0, so we get 0 is equal to 3x, so x is equal to 0. And then we can substitute that into our original equation. So just quickly, y is equal to e to the 0 minus 3 to the times by 0. E to the 0 is 1, so y is equal to 1. So our stationary point is at 0, 1. So there is a great example of working quickly and working well if you know your derivatives, you know your functions, you know your log laws, you know your exponentials. You can get to that answer really quickly. And that's sort of the expectation level that we should be at. Rightio, example 4. We have the equation y is equal to blah. It passes through the point 0, 3 and has a stationary point at -2, comma 9. Find a, b, and c. So this is a reading version of these graphs. How can we write this in function notation, this information, so that we can make a bunch of equations and then solve? So this first one passes through 0, 3. So f of 0 is equal to 3. We're also told it has a stationary point at -2, 9. That means it has to pass through that point. Let's just start with it has to pass through that point. So f of -2 is equal to 9. And then we also have, well, that's a stationary point. So that must mean the gradient, so f dash of -2 at that point, the gradient, since the stationary point, must be 0. So I have 3 bits of information. Now I can substitute all 3 of these individually into this original equation. Substitute in what's in the brackets for x, substitute what's at the end for y. I get 3 equations that has 3 unknowns, which means I have simultaneous equations. So I'll write out the equations quickly for you. We're going to get negative using this first point. I'm going to come over here. We get 0, not 0. We get -3, which is our y value, is equal to 0 cubed plus a 0 squared plus b times by 0 plus c. And that simplifies straight away down into -3 is equal to c. So that gives us our c value. This second coordinate, f of -2 is 9, so we get 9 is equal to -2 cubed plus a by -2 squared plus b by -2 plus c. And that's c, since I already know it from there, I'm going to change that to -3. And then so I get to simplify that, that's -8 plus 4a minus 2b minus 3. Add the 8 is 17, take away 3. No, add the 3, 7 is 20. You get 20 is equal to 4a, take away 2b. So there's an equation. Now we substitute in this point. So this is f dash of -2 is equal to 0. So that means you have to differentiate this. So what to be able to substitute in? So y dash, and all of these f's I should have technically done as y. Y. So y dash is going to be equal to 3 x squared plus 2ax plus b. So I can substitute that in using that. So I'm going to get 0 is equal to 3 by -2 squared plus 2a by -2 plus b. I get 0 is equal to 4 by 3 is 12 plus, no, that's minus 4a plus b, so I get negative 12 is equal to negative 4a plus b. So now I have two equations left over because I already had my c sorted. So I've got two equations from there, and then I'd use simultaneous equations to solve those. So you can either use elimination or substitution. I would say that elimination is the best. Let's call this equation 1 and equation 2. We've got a positive 4a and a negative 4a. I would do 1 plus 2. Do 20 equals 4a minus 2b plus negative 12 equals negative 4a plus b. Your 4a's are going to cancel. You're going to get a nice lovely negative b is equal to, let's do it quickly, that's going to be 8 is equal to negative b, so b is equal to negative 8. Substitute that into one of the equations and you'll figure out what a is which. Let's sub into 1. We're going to get 20 is equal to 4a minus 2 times negative 8, so that's going to be positive 16. So we get 4 is equal to 4a, so a is equal to 4. So we got c is negative 3, b is negative 8, and a is equal to 4. Now we can do this on a CAS, and I have an example using different numbers over here on my calculator already, but I'm going to update those really quickly to actually match that problem that we've just been doing. So we had, and we should get the same answer. So we've got the same equation, x to negative 3 plus ax all squared plus bx plus c. And so what we do is we first define our function. So I've defined my function there. Okay, as f of x. Then in the textbook, it says you have to define the derivative itself. It has this instruction here, define the derivative itself, but we can actually get away even quicker just going to define the derivative as g of x is equal to the derivative of f of x, and it automatically differentiates it for us, puts the a's and the b's in the right spots. That's all fine. And then we just have to be really careful with our substitution. So our three key points we knew was y of 0 was equal to negative 3. So let me change that 5 to negative 3. We were also told f of negative 2 was equal to 9, and then our derivative, which we've called g of x in our CAS, it's not f or y dash or f dash, it's g of negative 2 was also equal to, the gradient was 0, and we just got to be careful, we need to tell it we're solving for a, b, c. That's what we used up here in our originally defined function. Hit enter. And it's going to rerun again, and we get a is equal to 1, b is equal to negative 8, and c is equal to negative 3, which was the same as our answers. A was equal to, what did I write 4 before? A is equal to 1. 4 equals 4a, divide both sides by 4, a is equal to 1. B was equal to negative 8, correct. C was equal to negative 3, correct. So again, if you've got a CAS active exam question, all you're working out would be, okay, is this bit here with the word let in front of it. Let those things happen, and then you put your answer from your calculator. A is equal to 1, B is equal to negative 8, C is equal to negative 3. You don't need to show yourself manually doing the substitution. You don't need to show yourself even finding derivative. If it's CAS active, it's assumed that you're applying your knowledge of mathematics and your CAS skills in the CAS and doing the correct things in the CAS, and that you understand the context to get the right answer. And there we go. We found A, B, and C. That's a bit longer. There was a simultaneous equation there and lots of examples, but hopefully you found that useful. And hopefully starting to get an idea of how quickly we should be working. Any questions, as always, comment below or shoot me an email.